Hey Amanda, so I'm going to go through each of these IXLs into a score of 70 so that you can understand all the different levels and exactly what this IXL is looking for. So I'm starting off here with N1, and N1 is just basically identifying whether the polygon that's given to you is a trapezoid. Now there are two conditions for a trapezoid. One, it has to have only 4 sides, and two, that 2 of those opposite sides would be parallel. Since this is a quadrilateral, right, a polygon with 4 sides, and those opposite sides are parallel, as indicated by these little arrows, then yes, this would be a trapezoid. Same here, quadrilateral, 2 parallel sides, yes. This is not, here you do have parallel sides, but it's more than 4 sides, so no. Again, 4 sides, 2 opposite sides that are parallel, so yes. This does have 4 sides, but 2 opposite sides are not parallel because you don't see those arrows, so no. Same thing, here we have 4 sides, actually we have 5 sides, so no. So they try to trick you with some of those parallel sides, but you have to make sure that you have 4. So these are all quadrilaterals, all of which have parallel opposite sides. So all of these are considered trapezoids. Here, 4 sides, opposite sides are parallel. So yes, 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 and yes. 4 sides and parallel, this is 5 sides, so no. 4 sides and parallel opposite sides, and same here, so yes. Same thing, these all are quadrilaterals with parallel sides, so yes. Last one here, this one has 6 sides, so this is not a trapezoid. This has 4 with those parallel opposite sides, as well as this one and this one. Okay, so that's N1. Let's go to N2. This is to classify quadrilaterals. So just so you know what the different quadrilaterals, here we have all of them. We have trapezoids, we know what a rectangle is, we know what a square is. An isosceles trapezoid just means that you have 4 sides, you have the 2 opposite parallel ones, but an isosceles trapezoid would mean that this is the same as this. Whereas over here, this one may not be the same as this one. For a rhombus sometimes very much looks like a square, but for a square, all of these would have to be 90 degrees, whereas a rhombus, these do not have to be 90 degrees. However, the opposite sides would be congruent, angles would be congruent. Parallelogram just means that this side is parallel to this one, and then the opposite sides here would also be parallel. And with a kite, kites mean that, well, it looks like a kite, right? But these 2 sides would be congruent, and then these 2 sides would be congruent. Okay, so now let's see about classifying them. And there are additional properties to each of these quadrilaterals, which I'll discuss as we complete this IXL. So here we have 2 opposite sides. They are clearly parallel to each other, and they're also congruent, so this would be a parallelogram. It cannot be a rectangle because the angles would have to all be 90, and it can't be a square or a rhombus, because a rhombus has all, just so to clarify, a rhombus, all of these sides here would also be congruent. That's why sometimes a rhombus is also a square, only if all of these angles here are also 90 degrees. Here, this is clearly a square because all of the angles are 90 degrees and all of the sides are the same. But all squares are also rhombuses, simply because all of the sides are congruent. Oh, just kidding. So as you can see, I got this one wrong, but here's the explanation. It's also a square and a rectangle, and that's my fault. I'm sorry, a parallelogram and a rectangle. For something to be considered a parallelogram, the opposite sides have to be parallel, which they are. And for it to be a rectangle, it's the same thing. Opposite sides are parallel. the sides don't necessarily have to you don't have to have different sides for it to be considered a rectangle. So all squares are rectangles, but not all rectangles are squares. So yeah, let's try another one. This one has all congruent sides, so that would be a rhombus. And since you can see here that the opposite sides here are parallel, this would also be a parallelogram. It's not a square or a rectangle because the angles are not 90 degrees. This one here, it's clearly a rectangle because we know what rectangles look like. It's obviously not a square or a rhombus because all the sides are not congruent. But this would also be considered a parallelogram because all rectangles are parallelograms since the opposite sides would be parallel. Here we have the opposite sides are congruent. The angles don't appear to be 90, so it's not a rectangle, but it is a parallelogram. And all the sides are not congruent, so it's not a square or a rhombus. We learned from the last example that we got it wrong. These opposite sides here are parallel, so parallelogram. It is also a rectangle because all the angles are 90 degrees. It's also a rhombus because all sides are the same. And it's also a square because all sides are the same and all angles are also 90 degrees. Here we have all sides are congruent, so that's a rhombus. And all rhombuses are parallelograms. No matter what, all of these quadrilaterals here are going to be parallelograms because in order for it to be a rhombus, the opposite sides would have to be parallel, and same thing goes for squares and rectangles. This one here, this is a kite, and it's obvious that it's a kite, so kite. And it's also a quadrilateral because we have 4 sides. But this is not a parallelogram because none of these sides here are parallel. Okay, here this is a trapezoid, and since these 2 sides here are congruent, this is an isosceles trapezoid. It is not a kite because you have these parallel sides, and kites do not have parallel sides. It's not a rhombus, right, because not all sides are congruent, but it is also a quadrilateral because we have 4 sides. For this one, not a square, not a rhombus, definitely not a kite. This is only a quadrilateral because it has 4 sides. All right, that's it for that one. Let's go to N3, which is basically a little bit more of the same thing. So is a kite always a quadrilateral? All of these shapes here that we've been seeing are quadrilaterals because it has 4 sides. So yes. Is a rectangle always a rhombus? No, because rectangles can have opposite sides, adjacent sides, so ones next to each other would be different. So no. Is a quadrilateral always a parallelogram? And this is a no because we know that kites are quadrilaterals but are not parallelograms. So no. So a lot of the times when it comes to answering these questions, we have to kind of think of what is a counterexample, meaning what would make this statement false. And sometimes that helps when identifying if this is true or not. Is a rhombus always a parallelogram? Since a rhombus has all congruent sides, all of those sides would run parallel to each other, so we would say yes. Is a trapezoid always a quadrilateral? And that is the definition of a trapezoid. It has to have 4 sides, so yes. Is a parallelogram always a rhombus? And this is not exactly true because parallelograms could also be squares, could also be rectangles. As long as the opposite sides are parallel, then it's a parallelogram. But with a rhombus, it's more specific. It is a parallelogram, but it has to have all congruent sides, so no. Is a square always a rectangle? This is yes. And that's because the definition of a rectangle is that it is a quadrilateral, it has all 90 degrees, and opposite sides are congruent, all of which are qualities of a square. Is a rectangle always a parallelogram? And this is yes, because opposite sides are congruent, they are also parallel. Choose a word that makes this sentence true. A kite is always a quadrilateral because a kite will always have 4 sides. Let's just do one more. A parallelogram is sometimes a square. That's because you can also have what's it called, a rectangle. You can also have a rhombus. Those are all also examples of parallelograms. So it's not always a square, but it's not never a square. So sometimes. Okay, let's go to N4. Now to complete N4, I'm going to switch over here. And these are examples, and I'm doing it here because I will need to write to work this out. So for N4, you're given properties of a parallelogram and you have to find these missing angles or sides. So it says here that one angle of a parallelogram measures 80 degrees. And what are the measures of the other 3 angles in the parallelogram? So something to know about parallelograms. If this angle is 80, then the opposite angle will be the same. So 80 would be one of those answers. Then these angles would also have to be the same because opposite angles in parallelograms are going to be equal. So in order to solve this, we know that all quadrilaterals have angles that add up to 360. So we would add 80 plus 80 plus, and I'm going to call this x and x because I don't know what these angles are. So we'll just say 2x is equal to 360. 80 plus 80 is 160. So basically we're using this equation to solve for x. So then subtract the 160. We get 2x is equal to 200. Divide by 2. So x is equal to 100. So these angles here are 100 and 100. Same thing here. For a parallelogram has one angle that measures 130. So that means that another angle has to measure 130 because the opposite angles are congruent. And then we have 2 additional angles that are also the same that we don't know. So 2x is going to equal to 360. So 130 plus 130 is 260. We subtract. And we get 2x is equal to 100. Divide by 2, we get that x is equal to 50. So the other 2 angles would have to be 50 and 50. A parallelogram has one angle that measures 32.5. What are the measures of the other 3 angles? So again, we know that the other opposite angle would also be 32.5, right? Because again, oops, that's not a parallelogram. So we know that, let's just say this is 32.5 and this would be the same. And then we don't know these 2. So 32.5 plus 32.5 plus, again, 2x would equal to 360. If I add these 2 together, 32.5 plus 32.5 is 65. We subtract the 65, and we get that 2x is equal to 295. Divide both sides by 2. We get that x is equal to 147.5. So each of these angles here would be 147.5. This next one, 2 angles of a quadrilateral measure 150 and 110. The other 2 angles are in a ratio of 2 to 3. What are the measures of those 2 angles? Now here it doesn't tell us a parallelogram, it says a quadrilateral. So all of these angles could be different because it could be like a weird looking shape. It doesn't necessarily have to be any of those that we've looked at before. So all of these angles could be different. But if you were to add all of those angles together, it would still give you 360. So we're going to use this ratio to help us. And how you set up an equation would be 150 plus 110 plus, now we use this ratio, 2x plus 3x is equal to 360. 150 plus 110 is 260 plus 5x is equal to 360. We subtract the 260, we get that 5x is equal to 100, and then we divide the 5, so x is equal to 20. Now this is not my answer, but this is going to help me. This is the ratio, 2 to 3. So one angle is 2x, and the other angle is 3x. So we plug it in. 2 times 20 is 40. And then 3 times 20 is 60. So those are my two angles, 40 and 60. Let's try another one like that. We have a quadrilateral has two angles that measures 180 and 40. The other two angles have a ratio of 3 to 11. So we set it up just like the other one. 180 plus 40 plus 3x plus 11x is equal to 360. And that's again because of this ratio. 180 plus 40 is 220 plus 3x plus 11x is 14x. And this equals to 360. So we're going to subtract the 220 and we get 14x is equal to 140. So x is equal to 10 once you divide the 14. Now that I have x, I use my ratio one more time to find those angles. So 3x and 11x. We plug in the 10, we get 3 times 10 is 30, and 11 times 10 is 110. So those are my two other angles. Last one, two angles of a quadrilateral measure 4 and 216. The other two angles are in a ratio of 9, so plus 9x, and 19, so plus 19x, and this equals to 360. 4 plus 216 is 220, plus 9 plus 19 is 28x, and this equals to 360. Subtract the 220, we get that 28x is equal to 140. When we divide by 28, we get that x is equal to, hold please, 5. So now to get those two angles, remember 9x and 19x. So we plug in that x value in here. 9 times 5 is 45, and 19 times 5 is 95. So those would be my two angles. Okay, so now we're moving on to N5. With N5, you are going to graph whatever they tell you to graph. So in this one, it says a rectangle with these vertices. So you just basically plot those points, and then that's it. Whoa, I must have plotted something wrong. Let's try that again. Okay, so we have 10, 4. So 10, 4, 3, negative 9, 3, negative 9 over here, negative 10, negative 5, so negative 10, negative 5, and negative 3, 8. Here we go. Now that's right. Same thing, 3, negative 3, 7, negative 3, 1, 10, and negative 3, negative 10. negative 3. Oh, sorry, negative 3, 10. So that's negative 4, like that. Okay. I mean, basically, that's all you're doing. You're just getting these 4 points and you're plotting them. So 6, 0, 6, 5, 9, 1, and 9, negative 4. Oh, you got to be careful with those points, man, like, because then this will happen. But we got this. I mean, when you're given your 4 points, you just plot the 4 points on there. Let's go on to the next level just to see if anything changes. Okay, so here you're only given 3 coordinates, and you're going to need to find that 4th coordinate. So let's go ahead and put these 3 first. So we have negative 1, 10, negative 6, 10, negative 9, 6, 9, 6, and the last one. Now, when you're doing the last one, you have to keep in mind that everything has to match. So for a rhombus, all sides are equal. The sides that I'm doing here, this bottom side has to match this side. So since this side is 1, 2, 3, 4, 5 units long, I have to make sure that this side is also 5 units long. So 1, 2, 3, 4, and 5. This is a square, so we're going to go ahead and do that. So 2, negative 3, negative 1, negative 3, negative 1, 0, and so to create the square, it will be right here. This is a rectangle, so 5, 4, 4, 4, 4, 8, and then for that final coordinate, it would have to be here to create the rectangle. So it's basically just common sense. We have another rectangle at 1, 10, 7, 10, 7, 10, 7, negative 7, and so the final point to create this rectangle would have to be there. Okay, let's just do this last one here because it's a parallelogram. So we have negative 4, 5, negative 4, negative 7, negative 3, negative 6. So in order to this be a parallelogram, same thing, the opposite sides have to be congruent. So we would have to come here and look, you make sure that the slope of the opposite sides are the same as well. So this is only one diagonally across. This one has to be the same. That's it for N5. Now the last one is N6, and I'm going to go back here to my flip chart. So a couple things to keep in mind about properties of a parallelogram. Opposite sides are going to be parallel as well as congruent. So if this is 5 units long, then this has to be 5 units long. If this is 7 units long, then this has to be 7 units long. Your opposite angles here, as you can see, are congruent. And then adjacent angles, which are the ones that are next to each other, these would add up to 180. So if you have 105.14 and you were to add 74.86, that would give you 180 degrees. So consecutive angles, which are the ones that are right next to each other like that, not opposite, are supplementary, remembering that it's 180. And then additionally, the diagonals bisect each other. So if this is my diagonal and this is my diagonal, that means that this side is the same as this side, and this side is the same as that side. So let's look at some of those questions from that IXL. Remember that opposite sides here are congruent. So that means that 7s would have to equal to s plus 30. So we use this equation to solve for s. So I'm going to have to subtract this s here. So 6s is equal to 30, and then divide the 6. So s is equal to 5. Here, these are consecutive angles. If they're right next to each other like that, that means that these two add up to 180. So 2z plus 9 plus z is equal to 180. 2z plus z is 3z plus 9 equals 180. Subtract the 9. We get 3z is equal to 171. And then divide the 3. We get that z is equal to 57. So get another one. Again, same thing here. These here are congruent, so we make them equal to each other. S plus 20 is equal to 8s, minus 71. So we're going to combine all of the s's. So I'm going to subtract this s over here. So 20 is equal to 7s minus 71. Let's add the 71 over. So 91 is equal to 7s. Divide the 7. So s is equal to 13. Here, these are opposite angles. So anytime it's anything that's opposite are the same. Okay, so if the angles are opposite each other, they're equal to each other. If the sides are opposite to each other, they're equal to each other. But if it's next to each other, only angles though, that means that they add up to 180. So these two are opposite, so that means that they equal. So 2v minus 52 is equal to v. Let's subtract this v. So we have v minus 52 is equal to 0. So add the 52, and we get that v is equal to 52. So that is the measure of angle V. Now, or rather, that's the value of V, which is this angle here, right? So this is 52, and this is 52 in total. But they're asking for the measure of angle S. So S here is this angle, keeping in mind that these two have to add up to 180. So to figure out S, we would have to do 180 minus 52, which is equal to 128. So that is the measure of angle S. So always pay attention to what it's asking for. Like here, I actually forgot. Okay, it says that CD, and CD is just S. I happen to solve for S, so that's what it equals to. But if it asked for CB, then you would have to take the 13 and plug it in. Last ones here had to do with the diagonals. So it says that uy, so this part here, is t plus 15. And wy, which is the other part of the diagonal, is 2t plus 10. And we want to know the measure of uy. So all of this, that's what we're trying to find. Since these diagonals bisect each other, that means that this side is the same as this side. So we make it equal to each other. T plus 15 is equal to 2t plus 10. So let's solve for t. I'm going to subtract over here. So 15 is equal to t plus 10, and then subtract the 10. So t is equal to 5. Now it's asking me for uy, and uy is t plus 15. So I take the t and I plug it in. 5 plus 15 is 20. Last one, we have FH. So this part here is 20W minus 24, and FJ is 8W. And we want to find FJ, so we want to find the entire thing here. So you have to solve for W first. This is equal to this. So 8W is equal to 20W minus 24. Subtract the 20W to both sides. We get negative 12W is equal to negative 24, and then divide the negative 12. So W is equal to 2. But remember that we're looking for FJ, which is 8 times W. So I multiply 8 times 2, which is 16. And those are all of your IXLs.